All right, let me go over a slightly different looking function. This one is a rational function, but we're doing the same thing. We're going to find the difference quotient, simplify it, and then once it is simplified enough, we're going to plug in some x and h value to see what is approaching as x gets closer and closer and closer to 0. All right, so difference quotient formula. What is it? It is f of x plus h minus f of x divided by h. So that is the formula for difference quotient. First thing that we're going to have to do is we're going to have to plug in this x plus h into f. The function is divide 3 by whatever your input is. Okay, divide 3 over whatever that input is. And whatever that input is this time is x plus h. So the top of the fraction will be an ugly mess. Okay, take a look. I'm going to have to say, all right, this piece right here will be 3 over x plus h. Okay, because they said if you want to plug in something into this function, it's going to have to be 3 divided by whatever that is. That's why I have 3 over x plus h here. Now, what's next? They said do the minus sign, right? They said do the minus sign. And then subtract what from it? The f of x. F of x is 3 over x. So I'll say 3 over x. And once I subtract these two fractions, I will divide them by h. Okay? But in order to subtract fractions, remember they must have common denominator, right? Do they have a common denominator now? Oh, no, they don't. So we're going to make common denominators so that we can actually subtract them, okay? So how about I use some room down here? I'll say this is 3 over x plus h. I'll put my original denominator in the parenthesis, minus 3 over x. Oh, I don't want to put x in the parenthesis. And when I'm done subtracting these, you notice what I wrote down is just the top of the fraction, right? What I just wrote down is the top of the fraction. I will go ahead and multiply this by 1 over h when I'm done, okay? See, dividing by h is the same as multiplying by 1 over h. So they're talking, it's the same thing. I just didn't want to have a fraction within a fraction. So I pulled out the h for right now. On the same line, let me go ahead and put some common denominators here, okay? So notice the first fraction has x plus h. So I'm going to go ahead and put x plus h in the second fraction too. Multiply the top and bottom by x plus h. Now they look somewhat similar, right? Now, the second fraction had x in the bottom. So that's what I want to put on the first fraction. So on top and bottom, I'm going to put x and x. Magically, they have common denominator. Now we're ready to subtract them. So if I subtract them, I will get a big fraction, right? A big fraction bar. When the when the denominators are matching. All right, hold on. I want to pick this color. That pen is a little too thin. Hold on. You notice that the denominators are the same. I'm going to go ahead and just write that once. X times x plus h. But now I need to put the numerators together. And for the numerator, we have to be careful. Look, okay? It's going to be 3x minus 3 times x plus h. Okay, so what I'm highlighting in orange is what the numerator is. While I'm here, let me go ahead and distribute the negative 3 in. Okay, and you mean like, what do you mean negative 3? Look, this negative sign right there, I'm just going to treat it as the sign for the 3 here, okay? We're doing 3x minus 3 times x plus h. So when I distribute this, I'll first bring down that 3x. I'm just going to bring that 3x down. And I will have, let me write that in a hot pink color. I will have negative 3x and what? Negative 3h. And that hot pink is from distributing the negative 3 into x plus h. Okay? I'll simplify that, but when I'm done, I will multiply that by 1 over h. I'm happy to see that the 3x minus 3x will cancel out. Yay. This will cancel out. Goodbye. So the only thing that I have left on top of the fraction is 3h, and that's getting divided by x times x plus h. Now look, I'm ready to take out the h because I have an h on top of the fraction right here, and I have an h in the bottom of the fraction right there. So here's my final answer. The only thing that's left on top of the fraction is negative 3. Negative 3 divided by x times x plus h. So we simplify the difference quotient for this rational function. That was a great review problem, don't you think? We had to remember how to subtract rational expressions, talked about common denominators, being very careful with distributing a negative number. The whole party, this was a great one. Well, now I have a simplified difference quotient, this guy right here. I'm ready to plug in my x and h values in here, okay? So the difference quotient we got simplified was negative 3 divided by x times x plus h. And guys, this part will be the easiest part for you, right? All you gotta do is plug in x of 2 and h of these, getting smaller, getting close to 0, okay? So let's see. I'll use my first color, negative 3 divided by x is 2. So I'll say 2 times 2 plus h is 2. So that's going to be negative 3 divided by, what's that? 2. I think it's easier to get a decimal because I can see what the numbers are approaching if it's a decimal, okay? Not just some excuse for me to use a calculator. Okay, I was. All right, let me just use a calculator. But you know what I mean, though. If it's a decimal, it's easier to see what the numbers are approaching. So I'm just going to go ahead and type this in. And that came out to be, whoopsie. Oh, yeah, that's good. Negative 0.375. Okay, I'll go ahead and say that is negative, that was an eraser, negative 0.375. So that's the first answer. Next, I need to plug in what different number? Hold on, let me get a different color pen. X of 2 and h of 1. So it will be negative 3 times x of 2 and h of 1. Okay, so the only thing that I need to change, I believe, is the 1 in the bottom of the fraction. So I'll copy this, change the number being added to 1, and I can see that the next decimal is 0.5. Oh, sorry, negative 0.5. I don't know what I'm looking at right now. I don't know where we are getting close to. All right, next number. What if h is 0.1? So that will be negative 3 divided by 2 times 2 plus 0.1. Right, going to my calculator, copying this and changing the number being added to 0.1, and that is negative 0.71428. I'll just round this up to the nearest thousandth. Negative 0.714. It's not accurate. Maybe I should have done fraction. Maybe I should have, but hey. Fraction is not bad. But if I use the fraction, I can't really tell what the numbers are approaching. Like for right now, when I have the decimals, I can see the numbers are getting smaller. All right, let me do one more. I'm gonna plug in 2 for the x value and 0.1 for the y value. What's that gonna be? So I copy the same thing. I'm gonna put an additional 0 here. And okay, I kind of see the pattern now. They were trying to go to this negative 7.4 some number. Negative 0.746 I'll just round to the nearest is it 10,000th, nearest 4 decimal places. So if I write this down, copy that down from the calculator, I feel like it's definitely gonna stay in that -7.4 or -0.7 area. So maybe just out of curiosity, I'm gonna go ahead and just keep on going. What if it gets closer and closer? What if I put another 0? What if I put another 0? 0, 0. All right, I think it's pretty getting close to something. What if I put another 0, 0, 0? You see what I'm doing here? I'm getting really, really close to 0 for the H value. And I think I see where it is going. Do you guys see it? By me getting in closer and closer. Do you see it now? I think I see it. So by doing this numerically, I could see that the limit of the difference quotient, the simplified difference quotient, is approaching what? 0.75. It was going to -3/4. I wonder why it was doing that. I don't know. I think we will most likely work with polynomial functions when we do derivatives, but I will remember to use this example to connect it, because I don't know, I had fun with this example, the algebra piece, and plugging it in and just kind of plugging in a whole bunch of different H values to figure out that the simplified difference quotient was approaching a number, and I think that number is -0.75, right? But what does that mean? What does that mean, right? So we'll get to talk about all that in 1.4, okay? That's next Wednesday. So but for right now, that's enough. If you can simplify the difference quotient and plug in x and h to find these different values, maybe you will have to type in fraction on your MyLab homework, okay? But let me know, okay? So, but that was the second example for section 1.3.